Module 2, Voltage Regulation, Power Factor Correction, and Protection Systems. 2.1 Voltage Drop and Power Loss Calculations. Voltage drop occurs when electrical energy is transmitted over conductors with resistance and reactance. Excessive voltage drop leads to poor equipment performance and customer dissatisfaction. Power loss occurs primarily due to resistive heating in conductors and transformers. Engineers calculate voltage drops and losses to size conductors properly and ensure that supply voltages remain within allowable limits. Efficient conductor selection reduces both losses and operating cost. 2.2 Power factor capacitors and applications. Power factor measures how effectively electrical power is used. A low power factor indicates inefficient use of power, leading to higher currents and increased losses. Capacitors are commonly used to improve power factor. Their applications include reducing distribution system losses, releasing system capacity to serve more load, improving voltage regulation, reducing electricity bills for consumers with power factor penalties. Capacitors may be installed at substations, on feeders, or at customer premises depending on the nature of the load. 2.3 Protection in distribution systems. Protection systems safeguard equipment and consumers from faults such as short circuits, overloads, and lightning strikes. Effective protection ensures quick isolation of faulty sections, continuity of supply to unaffected areas, safety for personnel and equipment. 2.4 Fault current calculations. Fault current is the current that flows during abnormal conditions such as short circuits. Its magnitude depends on system voltage, impedance, and fault location. Accurate fault current calculations are essential for selecting protective devices with adequate ratings and for designing equipment that can withstand fault conditions. 2.5 Fuses. Fuses are the simplest protective devices. They operate by melting a wire or strip when current exceeds a certain value. Characteristics of fuses include current rating, the maximum current it can carry continuously. Breaking capacity, the maximum fault current it can safely interrupt. Time current characteristic, how fast the fuse responds to overcurrent. Fuses are widely used in low-voltage distribution systems due to their simplicity and low cost. 2.6 Circuit breakers. Circuit breakers are automatic switching devices that protect systems by interrupting fault currents. Unlike fuses, they can be reset and reused after operation. Types include air, oil, vacuum, and SF6 circuit breakers. Selection depends on voltage level, fault current capacity, and operating environment. 2.7 Lightning arresters. Lightning arresters protect distribution equipment from surges caused by lightning or switching operations. They divert surge current safely to ground, preventing insulation breakdown. Their placement is critical at substations, on feeders, and near vulnerable equipment. 2.8 Coordinated protection design. Coordinated protection ensures that only the faulty section of a system is isolated while the rest continues to operate. Key principles include selectivity, ensuring the nearest protective device operates first. Speed, clearing faults quickly to minimize damage. Reliability, ensuring devices operate correctly under all conditions. Coordination is achieved by properly grading fuse and circuit breaker characteristics, setting relay timings, and using protection zones. Module 2 Summary. In this module, we examine voltage drop and power losses, power factor correction using capacitors, and distribution protection systems. We studied fault current calculations, fuses, circuit breakers, lightning arresters, and the principles of coordinated protection design. These topics ensure that distribution systems are not only efficient but also safe and reliable. Course conclusion. We have now completed the course Power System Distribution. Module 1 introduced distribution system planning and automation, load characteristics, transformers, subtransmission lines, substations, and system design. Module 2 focused on system performance and protection, including voltage drop, power loss, power factor correction, protective devices, fault analysis, and coordinated protection. Together, these modules provide a comprehensive understanding of how electricity is delivered reliably and efficiently to consumers.